So, as Sean said, I'm Chandra Prescott Weinstein. I feel like I should give a little bit of context. I'm a dark matter theorist, primarily a dark matter modeler. So, as I was listening to the talks, this is kind of the place that I'm coming from. So, I do have a little bit of a physics bias, but I am also a feminist STS person, science, technology, society studies, for anyone who doesn't know. So I am also, I guess, a physicist challenger. So that is also a bias I have. So I will just give that to the panelists. Um, so what I'm going to do is I'm going to ask the panel one question, and then I'm going to expect you all to fill in the rest. So while they're answering my question, I want you all to take the time to collect your thoughts. I know we just came out of two really interesting talks and haven't had a break. But I want you all to take the time to collect your thoughts, write down some questions, and then we're going to fill most of the time with your questions. I want to particularly encourage the early career researchers in the room to ask a question. This is a space where that should be welcome. So I'm going to be looking forward to seeing you all line up, as well as the senior researchers. I'm also going to remind everyone that as interesting as your comments are, we're looking for questions. And I'm comfortable interrupting people. So, keep it to the question. So I think the running theme that I heard across the talks, or the thing that came to mind for me, was really the question of the academic community's ability to characterize in mathematical or otherwise formal terms. Um, so one thing that stood out to me was the question of what constitutes a universal basis, or a universal set of subjects for characterizing a field. So in one talk, for example, the idea of a mathematics of consciousness, I wondered, for example, in that particular case, how would I know that I had characterized a universal set of states that was truly universal? And I'm thinking, for example, of Jose Esteban Munoz, who thought about queerness as futurity. For the fellow Star Trek fans in the audience, I might say infinite diversity and infinite combinations. Confronted with that problem of the Vulcan notion of infinite diversity and infinite combinations, how do we grapple with this question? And I'm interested in how that dovetails with our ever-changing notions of objectivity. I think there's a tendency for scientists to be trained into the idea that objectivity is a static thing that we have always lived with, but it's in fact something that's evolving. So actually, I'm going to give everyone an opportunity to respond, but I want to start with Sandra's take on some of these issues.
Okay. Well, two things. As a universal basis is not required to know something. So you can have. I'm not quite sure by universal basis what you mean. There has to be some assumptions that structure how we engage with science to make sense, or how we engage with nature to make sense of things. And so again, you can choose that by either. And there's many different frameworks to choose, and it's useful to have multiple frameworks. So you could choose either making, as the pragmatists do, the impact on practical experience, which is basically to look at things that are detectable from causal interactions, or you can choose mathematics. That was both an ancient and a current kind of way of saying that's going to be the kind of metric for what constitutes what's real. In philosophy, that typically tends to be a top-down structuralist view, read what's real off of the mathematics of our best physics, versus a bottom-up entity type of view, which is read off what entities there are by our experimental practices. My own view is you need both of them at the same time in order to acquire knowledge of what nature is. Now, with respect to objectivity, that's a big question, because once you accept a kind of pragmatist view, which puts the human in nature, objectivity is no longer characterizable as the thing that keeps most of the human out of the story. And it creates a different kind of set of standards for objectivity that you get from what you might call robustness, or the multiple critical discourse, or something that brings all of the perspectives in. When you get a perspective on what the protein structure is from NMR and you get another one from X-ray crystallography, it's not like you can say which one is right by holding that up to the protein. That is your access to the protein. All you get are these multiple perspectival views. And so what objectivity is going to be is something that's not a mirror or a map, but a negotiation.
So maybe just to offer a clarification, I'm in terms of a universal basis, I'm thinking, for example, is physics a good model for how physics happens, right? Or is physics a good model for how science happens? I'm kind of this universalizing. Maybe I'll have you pass the microphone to Nima and have him answer the question of, is shut up and calculate a good model for how people outside of physics should think about doing their science? Or is that your proposal?
Yeah.
Okay.
I don't know. I don't have anything, I don't think I have anything especially interesting to say about that. But this question about objectivity is, of course, extremely interesting in physics. Obviously, we think that that in a quite unambiguous way, where we think about objective reality, and objective reality exists, a truth of the capital T exists, we're trying to discover what it is. On the other hand, we've also learned, most famously with relativity and quantum mechanics, but even in more minor ways before and since, that we can't have a preconceived notion of what that objective reality is actually about. And it certainly is not about every grammatically correct sentence in the English language or any language that you might ask about the physical world must have an answer just because you can pose a question. So there's all sorts of things we know just don't make sense about the world. We can't talk about the position and velocity of a particle at the same time. We can't ask which photon which slit did the photon go through in the double slit experiment and so on. These are really profound facts that what's objectively real is not what you might have preconceived ahead of time is objectively real. So, but I think that puts us in fundamental physics, at least in an interesting situation, that we can and do care about the objective truth, but we're also really humble in what that objective truth is going to turn out to be about. And we have to keep an open mind about what it's going to be about, because it's changed already a number of times in radical ways, and it's very likely to change again in even more radical ways as we grapple with some of the questions that we're confronted.
Okay, so I'm going to remind people you can line up at the microphone if you have questions.
Listening to Nick Lane's talk about the feelings and sensations and branching of a prokaryote, of a simple bacteria, the question arises, how far down does this go? And I mean that seriously. There's a big problem, I understand, or at least there was, in quantum physics about what constitutes an observation. Quantum decoherence and all that. That I have read so many different interpretations of that. So, quantum level is several way down, way up, that way down below, smaller than what Nick Lane is talking about. Is there any connection there? What constitutes an observation in a quantum level system and the level of, well, for lack of a better word, observation or consciousness or sensing or however you wish to describe it? Are those just happen to be a linguistic accident that they sound related, or is there a deeper connection? So that's my big question.
So I'm assuming that's directed at Nima, but I also think it would be interesting to hear Nick's answer. Yeah. Okay.
Well, I would say if I was Roger Penrose, I would say that I mean, it's the sort of trivial comment that whatever we think of as our conscious experience of the world is somehow tied up with non-determinism, free will. And where does free will come from? Where does non-determinism come from? The only ultimate source of non-determinism we know of in the world is quantum mechanics. I think, okay, he said a lot more than that. There's 100 counters to this argument that we don't have to go through here. But since we don't ultimately know the explanation, I don't think it's entirely insane either, that it might have something to do with that. So there might be some sense in which the random, chaotic free will of elementary particles, which is what quantum mechanics is about, is somehow controlled and magnified into the experience of everything else that you're talking about. That's what Roger would say, anyway. Yeah, there are well-known counters to this argument. I don't find them. I don't find the counters. I certainly don't find the argument itself compelling. I don't find the counters especially compelling either. I think we just don't really know.
The simple answer is, at the moment, we don't know. I mean, a lot of the work that I've been doing in fruit flies on consciousness with anesthetics in the last couple of years the thing that's got me excited about it is actually the quantum physics. It's the electron spin, because electrons are spin polarized as they're transferred through the respiratory chain. It will generate magnetic fields. I don't know what else it does. It's too early to come up with any kind of an answer at the moment. But it's certainly an exciting possibility. I mean, just one general thing I would say is, to my mind, feelings are primarily about our kind of state in the world. You know, we are aware of our bodily state. It's not primarily about the movements of the heavens or whatever it may be. I don't really see kind of the simplest forms of consciousness as being anything particularly directly to do with physics, more about the survival instincts of creatures. So then how simple do those creatures get? And I was drawing a line at bacteria with a flagellum. So if there's any truth in what I was saying at all, then that would mean a lot of plant cells, which you can still anesthetize, are not conscious in a meaningful way. And that would also imply other bacteria that don't have a flagellum. I would link it with agency in that sense. I'm probably completely wrong about all of this, but you've got to have a hypothesis.
So while other people are lining up, does anyone else want to respond to that question or come back to objectivity?
Sure, why not? Yeah, I was always fond of this one response to the measurement problem in quantum mechanics. If you've got the kind of framework that says something special happens on measurement, is, well, what's measurement? And of course, there's the answer that goes back to von Neumann and Wigner, that has something very deep to do with consciousness. And that's it's not the only answer, but it's an interesting answer. One interesting role it might play in this context, say, of thinking about questions of whether, as Nick speculated, whether, say, cells might be conscious, is it gives us a possible way to test that kind of speculation by seeing whether cells can actually collapse wave functions. Not something we can do yet, but but eventually we'll run experiments with interferometers on cells and see whether cells can enter into the right kind of superpositions, and see whether and if they don't, then basically it seems to me that I listen to a lot of these talks and everything is getting smarter than it used to be. Mice are so smart, babies are so smart. Now cells are basically little geniuses these days. Yeah. Yeah.
Or is it bad? So
Yeah.
I'm not saying it's smart, but I completely agree with you about your cartoon about intelligence. It's nothing to do with intelligence.
I mean, I don't know if you were serious about the idea that somehow this, that cells we might actually get a solution to the hard problem out of this by looking at feelings. I mean, brains, we've got enormously complicated information processing. We've got the basis of agency and so on, but we still have the gap to consciousness. Now, cells, it's like, okay, it's very impressive they can do it at all. So yeah, they're little geniuses. They've got information processing far less sophisticated than that of the brain. I guess the question is, if there's a gap from processing in a brain to consciousness, isn't there at least as large a gap from processing in a cell to consciousness?
May I answer that? Yes, of course there is, and I'm not pretending that I'm covering much of the gap. But I mean, I sometimes show a picture of you and Christoph Koch with your bet for the case of wine, and you agree that there's no answer known yet. But I forget the words you use. But anyway, the point is, Christoph Koch, and I think a lot of the field has been looking for the answer in neural nets, and a lot of the field of AI has been looking to see, will consciousness emerge from artificial neural nets and so on. And I don't think we really at the moment, and I'm not a neurologist, but I don't think at the moment we have any way of really distinguishing between a neural net which is firing in a particular way and is conscious, so that we're consciously aware of it, and one which fires in with exactly the same processes and in exactly the same way, using exactly the same neurotransmitters and so on, which is non-conscious in one way or another. So it seems to me that that level of granularity is the wrong level of granularity to approach it. There's something to do with metabolism, and I may have got the mechanisms completely wrong, which is telling you something about your metabolic state in relation to the world. It's not to do with neural firing. It's not to do with information processing as such. It's simply a kind of state readout of your metabolism, and cells need to do that as well. So it's not a huge leap to go from how the hell is my wetware doing to a kind of a feeling. It's shit. It's doing badly.
So to come to Nick and David's thoughts, I'm sitting here and I'm full of billions, perhaps a trillion, really, really, really smart cells that are doing all sorts of processing things. And I am just completely unconscious of that. I think consciousness has pretensions. It's what's saying I'm in control. But even as I'm speaking now, I'm not constructing this speech in consciousness. It's coming into consciousness. As an evolutionary biologist, consciousness looks like something that's used for very special purposes. Most of what we do as organisms, we could say the cells have their own consciousness, but seems to be not there.
I can say very quickly, I'm only talking about one tiny fraction of what most people would talk about as consciousness, and I'm not suggesting that all our cells are conscious. To generate the kind of fields that I would be thinking about requires a particular mitochondrial morphology, which we can look for. It requires, in the end, it's much easier at the moment to do molecular biology to try and show what it's not. And if at the end of some years of trying to do molecular biology to show that it's really not anything to do with molecular biology as we understand it at the moment, then it's time to look for other things. But I'm not trying to explain consciousness. I'm trying to explain how a bacteria knows what its state is.
Just to add a tiny bit to the unity of the panel, there is one thing we don't know about consciousness is what it's for and what its function is. But I did read an interesting paper recently by Matthias Michel and Steve Fleming. They had a proposal that the function of consciousness was very deeply tied to the focus of Malcolm's talk. Somehow once we emerged to be on land, suddenly we had a lot more time to think, and that this was going to suddenly advantage. This is you showed advantage of certain kinds of long-term planning. Their idea was somehow that would actually give some kind of role for consciousness. You probably remember.
Yeah, I mean, I think there's probably room for multiple types of consciousness here, and the type that David and Nick is emphasizing is this phenomenal role of consciousness, and the type that you asked about is something different. And the phenomenal is something, you give propofol to an animal, they become unconscious, right? That there's some sort of basal thing that goes on, that maybe reticular formation is deeply involved. It appears not to be dependent on neocortex, if you look at Merker's work on this. But the kind of, there's a certain problem that emerged at the water to land transition that the Fleming and Matthias Michel paper, just out in BBS, or at least the preprint is out, goes on about, which is once you come up onto land and you start planning involves a simulation. And the index of a good simulation is how hard it is to distinguish from reality. And so if the brain is generating simulations of reality for the purpose of, for example, if you've got a mortal threat, you don't want to actually do trial and error with mortal threats. You want to actually roll that out in your brain and see if that's actually a doable action sequence without dying. And if it is, then you go and do it. But that's a simulation, and now you have two different realities in your brain, one simulated and one which is coming in from the outside world. And their argument is that with the onset of planning, you need to have a tagging mechanism, a metacognitive tagging mechanism that basically says, this reality is from the outer world and this reality is from the inner world. And problems with hallucinations and psychoses are where that tagging operation breaks down. And they marshal a bunch of really interesting empirical data, postdictive effects in consciousness, where if you mess with a stimulus within 400 milliseconds, you can get people to think that something that something that they experienced 400 milliseconds was actually modified by something that occurred 300 milliseconds later. And these postdictive effects are thought to interfere with the tagging mechanism and reach back and basically fool us. So there is this whole different way of thinking about consciousness, which is about the function of consciousness, which might actually be a little bit more empirically resolvable at the moment than the phenomenal consciousness, which I know it's definitely popular strand of consciousness work at the moment.
Go ahead.
Yeah, I'd first like to thank the panel and all the contributors to the event. It's been super interesting and wonderful. And this question is mainly directed to Dr. Chalmers. I've heard a lot of interesting arguments for what consciousness is, like the basis of like from quantum to biological to even like theological and spiritual. And in the pursuit of really naturalizing consciousness, they were kind of presupposing that consciousness is part of natural philosophy itself. So I'm kind of curious, what evidence has kind of convinced you and the rest of the panel that consciousness is something that can be naturalized at all and isn't something beyond in a way, right? Spiritual or something else, if that makes any sense.
Well, you know, I mean, I take an expansive view of nature, and I think consciousness is basically a datum. For me, it's like as clearly existing a part of nature as everything else. But I guess the question is, you know, what's convinced me that we can actually explain it in terms of, you know, more fundamental physical processes? And so I think, you know, I take those questions to be open. I mean, there is a serious difficulty of explaining consciousness. We don't have any great theories of it yet. We've got very large explanatory gaps which have not been crossed. But I guess I take the view that you have to try. And, you know, it's very, very early days in the history of it, in the science and philosophy of everything, especially in the science and philosophy of consciousness. We've only been doing it a few thousand years, after all. So I think basically, just we have to try. But I think we've already got enough hints. For example, you know, systematic connections and correlations between consciousness and the brain, even though we haven't isolated the neural correlates of consciousness yet. We've got enough systematic connections there that looks like we can at least build the beginnings of a science. Will that completely explain consciousness? Will there be deep mysteries that connect to, you know, spiritual and religious questions that we can't yet comprehend? It's entirely possible, but I just take the view that you know, we've got enough to be going on with. Thank you.
I just want to second that comment by saying, if we look at the history of science, something somewhat similar happened in the middle of the 19th century with being able to give a, if you like, scientific account of life. And life was outside of scientific accessibility, goal-directedness. There was no way you could put that into a physical chemicals, you know, structural account. And yet that happened. And so, I mean, there's probably people who still don't think that happened, but there's still people who think that we have a flat earth. So I'm not worried about them. But so I think from that gives us, I think, even more grounds for the kind of position that David suggested, which I fully endorse, that what it is we think consciousness is, what it is we think life is, changes in that process, but it isn't necessarily inaccessible to it.
So, go ahead, Nima.
Sorry, if I can just make a simpler, more trivial, but slightly more general comment. And at a much simpler level, we've encountered this in the entire history of physics, going back 400 years. At any point in time, you have an understanding of some phenomenon, and there's some phenomenon that you don't understand. And when you're at the frontiers, obviously some rules have to change. Something is new. The question is what attitude to take towards the novelty. And there's something I think in physics, John Wheeler described as the sort of two opposite attitudes of what he called radical conservatism and conservative radicalism. And Conservative radicalism is making a big list of all the assumptions and crossing them out one at a time to see what happens. Conservative radicalism, something crazy has got to happen with every new thing that's outside the previous paradigm. Radical conservatism is to push what you have under your feet now as far as it can possibly go. Often it involves extrapolating well beyond the sort of realms where the phenomenon that you've run into have first been discovered, but you keep pushing until something breaks. It's this second attitude, one way or the other. We've had so many examples in physics that at least there's some data to support this. It's this second way of doing things that has always been the right way to go. Even the biggest revolutions have never looked like take one of the previous assumptions and cross it out or get rid of it or just randomly make a leap into some crazy new territory. It's much, much better to push what you have as far as it can possibly go. Sometimes it really must break, and then an actual leap is needed, but only by pushing what you have as far as it can possibly go do you even have a better idea of the nature of the leap that you have to make. So I think it's sort of obvious ahead of time when there's a big mystery, the assumption, it's not useful to think that, oh, God, God knows what we'll need. We'll be totally different, entirely outside the scope of what we can understand. It's never been useful. And it's always been better to assume it can be done, given what you know, just pushing it further.
Thank you very much.
So I think I'm going to take moderator's prerogative before we go into the next audience question and say that part of what I'm hearing here is kind of an exchange about method and what methods, how we prepare ourselves for next generation methods, as well as the methods that we are using now. And I had never heard a talk about game theory before today. And so I was thinking about what Kevin said about how we should think of game theory not as a theory, but as a toolkit. And a toolkit for theory creation. And I was wondering if you could say a little bit more about that in relation to these questions of method and preparing ourselves for next generation method.
Yeah, and I mean, I think that actually to connect this with this question of like, do you completely dispose of a method that you have versus push it? One of the things the history of game theory has shown is, one of the things that the history of game theory has shown is that you can do a lot by pushing things out. So, the early days of game theory had all of these very rigid, very classical assumptions about, what people cared about and how they and how they reasoned. And then one of the big revolutions was it being incorporated into biology, where you're dealing with bacteria who aren't planning, who aren't, or at least not in the same sense. There certainly is no common knowledge of rationality between bacteria. And but nonetheless, the same tools can be used by reinterpreting their individual parts. And so you can use a method by reinterpreting what it's doing and adding a little bit of structure and taking away a little bit of structure. And I think that sometimes we make mistakes because when we have a theory and it seems to not be working, or have a method that seems to not be working in a case, we think we've got to throw it all away and invent something brand new. And then we end up coming back to discovering more or less the thing that we could have done already with the old one. And I think that that's one of the things that concerns me about the quickness with which some scholars are eager to dispense with game theory in particular. And I think this probably happens with other things as well, by saying, oh, this isn't, this version of it wasn't useful, so let's throw away everything, because that eagerness for paradigm shifting or revolutions or whatever, that's what wins you Nobel Prizes, I guess. So you want to do it, but oftentimes means that we end up throwing away things that with little tweaks could have been more successful.
Go ahead.
Thank you so much. Actually, my question was also for you, Kevin, and I guess it's in the same spirit of the question that was asked. So I like the idea of, getting rid of game theory as a theory and then thinking about things more instrumentally. But then I'm wondering, with respect to that, like what we want to index that instrumentality to. And I would love to hear more about that from the experience you have with game theory, because I'm thinking there of what people lose when theories are debunked, right? In terms of the stability for making predictions, but also integrating knowledge across different contexts. So if you could say something more about that. Also, does it make it like something that, I guess with your question as well, the background that you have, I'd be interested in this as well, when these sorts of instrumental ways of proceeding can maybe privilege certain groups when it comes to who decides what's instrumental or not for pursuit empirically?
Yeah, thanks a lot for your question, and I think that's right. I mean, the thing that's tricky with game theory in particular is that it's used for a lot of different purposes. You know, the classics in philosophy, it's used for both explanation and prediction. We want to predict how much people are going to pay for a certain product, and game theory might be relevant for that. But we also want to, especially in the biological cases, we're not doing very much prediction. We're mostly doing explanation. Why? What we know the peacock has a tail. The question is why, not whether it will. But there are also some very oddball, sort of hybrid normative empirical uses of game theory. So there's this area in economics called mechanism design, which is you are using game theory to decide what kind of contracts to offer your workers, or what kind of auction mechanism to use in order to sell a product, or something like that. And so you have both this composition of empirical prediction, because you have to predict what would happen if I did this auction, or what would happen if I did that auction. But you also, there's a normative component, because there's somebody who's bringing an instrumental goal to the table. I want to, if I want to auction off my house, I want to maximize the amount of money I get for it. And I think that connects with the last part of your question, which is this question about, like, who's deciding. In those cases, a lot of the instrumentality is decided by the person who's designing the mechanism, and that can be for good or for ill, depending on who's designing the mechanism and who it's being designed for, and what's the objective. And so I think that all of the issues that you raised are really are serious issues that come up in deciding, like, what is a successful use of this theory. And once you introduce that game theory can be used in this normative way to design policy and institutions and things like that, those problems are magnified, because now you have to ask for whose benefit is the policy being designed.
I guess since I was called on to say a couple things about this from the point of view of my background, having played a couple of leadership roles in decision-making processes in particle physics, in particular in relation to making the case for cosmic probes of dark matter in relation to what we imagine we could do if we had adequate US federal funding, which I realize sounds really laughable for me to say out loud right now. The thing that becomes really clear very early in the process, even who gets to be part of that conversation of what kind of particle physics, what kind of dark matter science would we want to do, what kinds of probes would we want to use, and even what defines a cosmic probe of dark matter is very heavily determined by someone's professional network. Whether you even get invited to be part of the conversation, whether the people who are leading that conversation make, for example, a decision to emphasize early career participation. So the Cosmic Probes of Dark Matter group of the Snowmass process did. There were other areas involving theoretical physicists that chose to be very exclusive and selective in who could participate in the process. And so you get a very different stamp generationally of who's invested. And that shapes how the next generation makes the case for whatever comes out in the report. So I will just say there's an element of this that is very culturally situated in who even gets to be in the room saying, this is what constitutes particle physics method, right? Part of the challenge we had to make was saying that observations with astrophysical phenomena were particle physics method. We had to make a decision about who would get to be in the room with us as we defined that on paper in a way that we hoped would make the case to another committee that would then tell the Department of Energy and the National Science Foundation what their funding priorities would be. And we were successful. We were more successful, in my opinion, than the people who were very exclusive rather than inclusive. And I think that's an anecdote, right? But it raises the question of what happens when you choose inclusivity and exclusivity for actually the scientific outcomes you have on the other end. There are epistemic implications, I guess I will say. So we have another question. Hi, Simon.
Hi, John. How you doing? It's very good to see you again. There's this comment, I think it came up in Nima's talk, but it seems to be implicit in a lot of the talks, which is that sometimes you get something you find something, either it's like a set of notations, or maybe it's, moving from the water into the savanna, where you get more out than you put in. And this is this phrase that's come up a couple times. And it's a mysterious thing, right? Usually in a closed system, right? I mean, you put stuff in, it only gets degraded. So I'm just curious if people could talk a little bit about these cases, either epistemologically, like Kevin, you've talked about game theory, for example, and Nima, the sort of the affordances of certain kinds of physical theories that work, or but also maybe in the biological world, there's some environments where somehow like you get more out than you put in. So I'm just wondering if people could talk about that.
Who wants to start? Malcolm, I'm going to pick on you because everyone's looking at you.
It's really intriguing to me how distal sensing seems to be such a key to so much complexity, at least in terrestrial life. And distal sensing, by distal sensing, I mean vision, which depends on electromagnetic energy from the sun. And we happen to be on a planet, I don't know how common this is, people who study exoplanets can tell me, where you basically have perfect transparency. And so with basically almost zero tweaks to the ancestral eye, you can be immediately in contact with things that are vastly further away from you, and with almost no energetic cost to you. You just have photons streaming in, reflected off that distant opportunity. Is it a threat? Is it an opportunity? Well, organisms move around, and they get occluded by plants who are trying to absorb the sun, and those plants are blocking rays of vision between things that are threats and opportunities to one another. And that ecosystem just gets a lot more churned up, like the temperature goes up, literally as well. Endothermy seems to be a key, which is weird, right? Why would endothermy be a key? Well, there's one basic thing, which is biochemical processes run significantly faster when they're warmer. And so analyses of neural computation suggests that endotherms their brains run on average about 6 times faster than an ectotherm that is at ambient temperature. So there are these trivial things about like the ecosystem and warmth, and then there are these complicated things about light being this very convenient distal thing that puts things in contact over long spaces if the ecosystem is convenient. If you're in a dense rainforest, it's not. If you're in a flat plain, it doesn't matter if you see things far away, because you can't do anything strategically there. You just have a speed gain. So the ecosystem determines so much of this.
I think I want to question this dependence on vision, because if you look at that's not the only way in which organisms sense. We're going to go back to the bacteria. Organisms sense their environment and respond to it. And so, and I mean, vision has been like vision in birds. Okay, this is what we've been studying because this is what humans are interested in. And this is how humans interact with the world. The birds is just because they're nice and we look at them. But if you look at the evolutionary biology, and if you look at, the kinds of, at least in the 20th century, early middle 20th century, that we focused on things that were really, this is about the perspectival inclusiveness that are about us. When we make up a very small part of the biota and on the planet, and maybe light, maybe the dark matter, dark energy thing is also putting that in a little bit of perspective, that there's lots of kinds of interactions that don't depend on light. And that's certainly true of biology, in a kind of microcosm, and maybe in the universe macrocosm. But I guess the thing is that I think the answer about what vision and long range vision gives you in a certain environment that's occupied by certain kinds of sensors is an important story, an important bit of knowledge about the world. But if you look at that there are some organisms that use olfaction, which is just chemical sensing. There's audition, which is just, audible sensing, and part of evolution is niche construction, which is creating and finding or selecting environments that then reinforce this amplification of the matching. And so I just wanted to open that up. Not that the vision isn't important for understanding the evolution maybe of humans and other primates, but that's a story that might get translated, applied, as Kevin said, that model of explanation to things that don't have those particular sensory capacities.
So I think, Sandra, what I also hear you saying is that the metaphors we invoke actually can shape how we think about the problem that we are trying to solve. Yeah.
About light more generally, I mean, most chemists working on the origin of life, as Mike Wong was saying, would have it starting in a terrestrial geothermal pond powered by UV radiation. I would have it starting down in the depths of the ocean. It can be actually on land as well, but it's about the pressure of hydrogen, partial pressure of hydrogen. Life is really powered by the flow of electrons coming from an electron donor like hydrogen to an acceptor, which could be CO2 or it could be oxygen in the case of respiration. And what light is doing in that context is forcing the flow of electrons from less willing electron donors. So there's forms of photosynthesis where you're starting with hydrogen sulfide, for example, and you're effectively transferring the electrons onto CO2. And suddenly you're able to get a free lunch pretty much by absorbing those photons and activating a chlorophyll which is strong enough to yank the electrons from hydrogen sulfide. Later on, probably, not everyone agrees, but oxygenic photosynthesis, where you have two photosystems linked together in series in the Z scheme, suddenly you now have the power to strip electrons from water. And that just completely transformed what was possible in the world. It made things, apart from anything else, you're accumulating oxygen in the atmosphere. You're not tied to hydrothermal systems as a source of electrons anymore. You can use the oceans. So so completely separate from vision, light allowed a ramping up over orders of magnitude of what was possible, using basically the same kit that you already had with just a few small changes, add chlorophyll.
The character of what you're asking about in the context of theoretical physics, I think, is a little different than what we just heard about. And I think there's an extremely simple, but of course, kind of deep reason for a lot more coming out than goes in when you're doing things right in theoretical physics. And the very simple reason is that human beings, certainly human theoretical physicists, suck. We suck compared to the grandeur of the world we're trying to understand. The genius is not in individual or even collective efforts of human theoretical physicists. It's in the magic and power and amazing features of the universe that's being studied. So the best work is interrogating that world. That, as I said in my talk, the most effective way of interrogating it is by asking it mathematical questions, listening to what it tells you to do next, and doing it. But the whole point is that it's vastly, vastly, vastly more powerful, more interesting than anything that you or all of your friends put together can possibly do. And practically speaking, what happens, and it's related to one of the themes of my talk, is that if you have a suspicion that the kind of physical questions that you're thinking about might be related, objects in physical world A might somehow be related to concepts in mathematical world X. If you're roughly right, the point is the business about the laws being simple and rigid means there are not that many ways that they can fit together. So all you have to do when you're in the basin of attraction of the right idea is sort of jiggle them around a little bit until they finally fit. When they finally fit, the number of things that comes out is just gigantically bigger than what went in, simply because of this business about humans sucking. But we get to interact with these wonderful objects because there's not that many ways that they can fit together. Rotating them around, just trying to make them fit in some way is something that we can do with our puny, pathetic brains. But the fact that they exist as these vast, wonderful things out there is something that's very easily beyond anything any one of us could could invent. So this idea of the existence of a Platonic mathematical universe and the actual physical universe being mysteriously linked to each other has real teeth. It means exactly this, that when you're ultimately finally doing things right, it takes a long time to get into the basin of attraction of the right idea. But once you're finally there, it doesn't take too long, and you know that you've done it right exactly when it feels like you're playing with an intergalactic spaceship. You push a button and zillions of things come out that you didn't expect.
Hello, thanks again for everybody for your remarks and for putting this together. It's fantastic. Quick question for Kevin Zollman. Can you speak a little bit to quantum game theory? I've heard it said, I know nothing about it. I've heard it said that it can explain human quirks in a way, or it can, I don't know if explain's the right word, explain human quirks better than traditional game theory, excuse me. And insofar as that is true, does that say anything about humans as little walking wave functions?
Yeah. So let me start off by just admitting my own bias here. I am skeptical of those claims. So quantum game theory, but let me step back and say a positive thing about it, which is that I think it is very interesting for the same reasons that game theory is very interesting. It's a reinvention. It's taking the same basic parts. Game is still the same thing. It's a set of players, a set of strategies, a set of payoffs. But now the ways that the players can randomize between their strategies is different because it's using things like superposition and notions from quantum mechanics. Although, to a certain extent, it reinvented an idea that already existed before, that was about the idea that players might correlate their strategies to one another, which was one of those ideas that also got invented twice even before that, once in biology and once in economics. The economics one is called correlated equilibrium, and obnoxiously, the biology one is called uncorrelated asymmetries. Scientists are terrible at naming things. But I think the quantum game theory is basically getting at that same idea yet a third way. So the reason that I say that I'm skeptical of it is I'm skeptical that it's actually doing something that we couldn't already do before. But on the other hand, great, have at it. Like I don't want to. I have yet to see a use of it that convinces me that it really does something new. But I have a puny brain like all of us, and somebody else certainly could be smarter than me and come up with an idea. And so I'm perfectly happy for people to pursue it, because I think that, with so many of these things, you don't really know what you're dealing with until you try it out a bunch of different times. So I'm a bit skeptical, but I'm not going to shut down anyone's research program for that reason.
Anyway, we are walking wave functions.
So we do have time for your question.
Well, I just wanted to point out a slight discrepancy between what Nima is saying and what Sandy is saying. So I think Nima is still thinking about the laws of nature ultimately as truths with a capital T, a Platonic world, mathematically formulated and all that. Sandy is arguing, well, somehow our human condition should be in there, in whatever practice of science we're doing. Nima will realize that in cosmology, we better take the observer into account because we're in the universe. And so I think the slight tension, and I'm just asking the question what you have thoughts on this, is that mathematical truths may seem objective, but may not be ultimately purely objective in the old Platonic way. Somehow, somewhere, it seems to me we have to get us into the equations. And that's maybe at the heart of the matter of this cosmological thing.
Can I make
just a
comment
thought
about this? But I can't remember if we had discussed this before or not. We very well may have discussed this. But indeed, I think for 400 years or 2,000 years, depending on where you start counting, we've always thought about what physics is about, in particular, science about more generally, as about some division of the world into something assumed or looking and the thing that's being looked at. And this was a little loose and implicit in classical physics. It becomes a crucial part of what it means to speak about objective reality, what's left of it in quantum mechanics. And absolutely, as I said very briefly in my talk, as you know very, very well, our probably very, very biggest, deepest challenge in fundamental physics today has to do with situations in cosmology where even that sort of in principle ability to divide the world into an infinite apparatus that's doing the looking and the finite things that are being looked at is made impossible. It's very profound. I think many of us don't know exactly what to do about it. But it does also seem to be the last thing which has not been unified. I mean, the last more than 100 years in the development of physics has been about realizing there's fewer and fewer things we're allowed to talk about. We went from Newtonian physics even to relativity. You know, in Newtonian physics, I could imagine talking about what was going on in Alpha Centauri now. I can't talk about that anymore after relativity. It's not a meaningful notion. We got to quantum mechanics, even fewer things that we could talk about. That's what depressed all the classical physicists, that the Laplacian dream of predicting the future was just not a true fact about nature. In more modern times, we've realized that we can't even talk about, because of gravity and quantum mechanics, we can't talk about observations in a meaningful quantum mechanical way inside this room. That gets us to the sort of holographic ideas where the only sort of observations we're allowed to talk about are things that are made far away at the boundaries of space-time at infinity. But then we're stuck in a situation like our own actual cosmology that we live in, where such observations are impossible. But every step in this journey has told us there's fewer and fewer things we're allowed to talk about. There are fewer and fewer meaningful objects that physics is supposed to be about. The silver lining of this has been that what's left has been more and more unified. So that's kind of inevitable. If there's fewer and fewer things you can talk about, then the things that you used to think were distinct have to be more closely related to each other than you realized before. So it's exactly this sort of crushing disappointment, the loss of determinism, that means that particles and waves can be the same thing. It's the fact that we can't have observations, meaningful quantum mechanical observations in the interior of space-time that allows gravitational theories and non-gravitational theories to secretly be the same. So that's been the silver lining. The march of unification and the march of fewer and fewer things we're allowed to talk about have been going in lockstep. It looks like the last frontier is this division of the world into the system and the observer. And cosmology, gravity, but especially cosmology tells us that we can't do that. And somehow the final revolution, and I suspect this really will be the final revolution, will be to figure out what that system-observer divide really is about. And I think in that sense, us or whatever the observer is going to have to not artificially be something outside the system, but inside it. I should also say, I suspect this is such a huge leap, the biggest of all the leaps that we've ever made, that my guess is that we're going to get there in the same accidental, random walk way, running into magical things along the way. But that's a strategy and a guess.
Okay.
You get the final word, so make it good.
You know what? I really like that.
I love it for you. I love it for us.
So I think this is really, in a way, about our stances and frameworks for understanding what mathematics is and how we approach the world that we're trying to, that we occupy and that we're trying to explain in order to facilitate the kinds of things we want to do. So there's a kind of means ends reasoning part of it too. But I think for me, what mathematics is, I mean, you can take it ontologically as basic and be a Platonist in the 21st century. But I think if you look at the history of mathematics and the history of science, what you see is that mathematics is a form of representation of what we think nature, the undescribed, I agree with you, this wondrous, incredible, but undescribed set of events, right, has structure. I'm a structuralist. It has structure, right? And it's not random. And that gives us a purchase on trying to use what we can to discover those structures and and they make us able to predict and plan and do all sorts of things. But in the end, the mathematics, I mean, I don't know if you want to be a Platonist, then we should have maybe stopped with Kepler, who did the Platonic geometry, and that's all Plato thought was the foundational mathematics. So mathematics changes too over time. And it develops new capacities of representation that are required as we get new data, we get new concepts to deal with how do we make sense of this undescribed world, and how do we decide which of those descriptions is accurate. And that's a question about, for me as an empiricist, of the alignment with those theories with empirical evidence, even though that all of these are fraught with representational and connective issues. And it's also a question of adequacy, which brings in the question of what do we want to do with this theory, and that will change what kinds of representations, what kinds of experiments, what kinds of things we need. So I think it's not that, I think there is an attitude towards mathematics, if you take it as the fundamental ontology of the world. I think there's been, for me as a philosopher, a kind of conflation between what we take as constitutive assumption of science, which is there are things outside of us and that we are part of, right? And that we are going to assume that they are physical or material foundations for explaining them, although those get reinterpreted. And to think that physics is identical with that kind of assumption. Because physics is a set of representations that is constrained by the kind of physicalist, materialist assumption, the same way biology is a set of representations that's constrained by that same kind of ontological assumption. So for me, mathematics plays I have a different stance towards what mathematics and physics and all these representations that humans come up with to characterize the unrepresented world are. And so I'm less optimistic that by being able to say less and less, we're getting closer and closer to some kind of truth. The other feature of that, and then I know I'm taking a lot of time. The other feature of that is that I think that we live in a open, at least in biology. Okay, now that's a subset of the things that are physical, the physical things as they are wont to be in biological organization. That's a system that's open-ended. And so as evolution occurs, and you maybe have, and I don't know enough about cosmology, but you may have a different view about the cosmos as changing, and the laws that govern it changing. The rules governing biological organizations certainly have changed over historical time. And so I just don't see the end in an open and in that kind of stance towards what we take nature to be. So I think these are things that aren't decidable by doing experiments, maybe by a fist fight, but they not by a fist fight. But they're no, okay. Well, somebody would lose, and that would be wrong. But they're maybe decidable by what they let us do, right? By inviting them all into the room and seeing what we get if we take this set of assumptions versus that set of assumptions. And we might get different things depending on if we're looking at evolving organic beings, and we're looking at more or less fundamentally context insensitive, stable fundamental phenomena. And so they may require different stances with respect to these kinds of assumptions.
Well, Malcolm, Nick, David, Sandra, Nima, and Kevin, thank you so much for the interesting presentation.